Hello dear friends, welcome to my channels. Today's discussion is continuity. Okay, continuity. This topic is very important, friends. Let x comma t and y comma v be topological space. A mapping f such that x tends to y is said to be at x0 belongs to x. If and only if to every v NBD of f. Must remember this point. Every v NBD m of fx0 must remember there exists a t NBD of n such that if n belongs to a subset of m. Okay, v NBD of m must remember v NBD of m means topological neighborhood. I have already told. Suppose f is said to be t tends to v continuous if it is continuous at each point of x. It is continuous at each point of x. So friends, what is continuity? Continuity means continuity. This is the main factor. Continuous at point x0. Okay, continuous at x0 means continuous at a point, and function is total continuous because when function is total continuous, when each point of x is continuous. Okay, continuous at each point, so it is continuous. So must remember fn subset of m. Now friends, I will give some example for more clearance. So friends, example, let x is equal to 1 2 3 4. Okay, x is equal to 1 2 3 4, y equals to a b c d. So t equals to phi 1 2 1 2 3 x, and v equals to phi a b bc d y. Okay, so friends, now the topology is defined on x and y. T and v is this topology, and f be a function from x to y defined as 1 b 2 c. This is the function. Okay, f is continuous, and at 4 I have to check. Okay, now I have drawn this function that 1 2 3 4. Okay, a b c, okay, d. When 1 is b, then it is b. When 2 is c, then it is c. And when 3 is d, okay, 3d, and 4 c. Okay, is it clear? Yeah. So list of v NBD containing CR. List of v NBD containing CR. Okay, you see that BCD, okay, another is Y. So it is B, C, D and Y. Must remember open set belongs to neighborhood. Open set BCD is open set, and largest open and another open and another NBD is in this, there is Y. Means always remember that open set belongs to or contain N. contains in N, means O belongs to N. Okay, O, this is my open set, belongs to N. I have already very clearly cleared this what is open set. So only BCD and Y is possible. And now you see that Fx is equal to BCD or Y. And now what is the condition of the topological continuity? Continuity condition is Fn subset of M is VNBD. VNBD is, this is my VNBD, this is my M. Okay, this is my M. M is VNBD. NBD is VNBD BCD, comma Y. This is my VNBD M BCD. BCD I can say M. And capital N is NBD TNBD. NBD N is TNBD. So TNBD is TNBD is 1, 2, 3, 4. Okay. TNBD is 2. TNBD means 1, 2, 1, 2, 3. Okay. TNBD is N equals to in here 1, 2 and 1, 2, 3. Okay, and X. Now Fn subset of, my point is x0 equals to 4. Okay, my point is x0 equals to 4, so that 4 is NBD is only X. Fx is only NBD of 4. Okay, NBD of 4 means Fx means 1, 2, 3, 4. Okay, 1, 2, 3, 4 Fx, because only one NBD, that NBD is X. So Fx subset of whatever you see, Fx subset of BCD. Okay, BCD. Okay, BCD. So which is M. Must remember BCD is also subset of M. So BCD Y any number. So we see Fx proper subset of M. So now I think I can clear. So if F is continuous at 4, this is correct. F is continuous at 4, this is correct. How? Because friends, 1, 2, 3, 4 is the NBD of 4. That is called N, and we see 1, 2, 3, 4 has also same value, that is BCD. BCD we can get. So BCD, so Fx is containing BCD, so F is continuous at 4. I think I can clear, there is no doubt. Now friends, there is the same questions. Okay, you will see same example, but question is asked only continuous at 1. Okay, my previous question here is I have to check that f is continuous at 4. Now I have to prove f is continuous at 1. So how it is 1 is continuous, that I will discuss in my class. Now please pay attention. So friends, f1 equals to b, f1 equals to b, and I have to check if f1 equals to b means 1, this is image. Okay, I get only one image, f1 equals to b, and I have already told that NBD means n. Okay, for the t case is n equals to NBD of 1 equals to 1, 1, 2, 1, 2, 3 and x. Okay, this is my NBD of 1. These are 4 NBDs. Yeah, it is clear. There are 4 NBDs. So if 1, so f1, what is the value of f1? f1 is obviously b. I get the value f1 equals to b. Similarly, f12 equals to bc. Okay, f12 equals to bc. And if 1, 2, 3, okay, if 1, 2, 3, whatever I get, if 1, 2, 3, the value 1 for B, 2 for C, and 3 for D. Okay, this concept, this is the image. Okay, so if 1, 2, 3 is equal to BCD, and fx equals to BCD. So what is my condition, friends? I have already told that Fn means neighborhood of 1 subset of M. Okay, clear friends? I hope it is clear. Fn is subset of M. So if Fn equals to subset of M, so you will check that 1, 1, 2, 1, 2, 3. So it is B, BC, BCD, BCD. So you will see that BCD is also present in here. BCD is also in here. B is also in here, and BC I have to check. BC is in here. BC BC I do not see any BC. So it is, so x equals to 1 is not continuous, friends, because if it's not continuous, because must remember, friends, must remember, if is not continuous, if is not continuous, because you see that only BC is not contain, does not belongs to V. Okay, each element, the condition is that M is VNBD. One minute. Have BC. Sorry, F1. Now this is the containing node. It is also NBD. This is also NBD of M, because BNBD of M. So you see BCD. So all are, so if X equals to N is continuous. So I prove this. F is continuous at 1. Now friends, another question is that let X equals to 1, 2, 3, 4 and Y equals to ABCD and T equals to phi 1, 1, 2, 3, X and V equals to phi A, B, B, C, D and Y. So B topology is defined on X and Y. And let f and g be a function from x to y defined by f equals to 1, b, 2, c, 3, d, 4, c and g equals to 1, a, 2, a, 3, c, 4, d. So friends, we need to check f is continuous or g is not. We have to prove this. Before this, I will tell one theory and I will also write this theory after this problem, that is a function f such that x, t and y, v is continuous of x if and only if the inverse image of every V open set is T open set. V open set is T open set. So first question is, I have already drawn, that is 1, 2, 3, 4 A, B, C, D. So it is 1 to B, 2 to C, and 3 to D, and 4 to C. Okay. And list of V open sets are, list of V open sets means in here list of V open set is phi A, B, B, C, D, Y. So that is list of V open set is phi A and B, A, B and B, C and D. Okay, list of phi open set and B, C, D and Y. Okay, clear? So F inverse phi equals to phi and F inverse B equals to 1. F inverse B equals to 1. F inverse C equals to, okay, F inverse B equals to 1. F inverse A, B, because must remember A, B is my, so it is A, B. Okay, A, B equals to F inverse A, B equals to only 1, because from A this is null set and F inverse BCD. Next is F inverse BCD equals to, for B it is 1, C for 2, 3, 4. Okay, F inverse BCD equal to 1, 2, 3, 4 equals to X. So we get everything, friends. What is the question? According to the question, according to the theory, a function f such that x comma t such that continuous of x if and only if the inverse image of every v open set is also open set, because you see that all are open set. 1 F inverse 1, 1, 2, 3, 4 all are 1, 1, 2, 3, 4 all are open set. Okay, is it clear? I hope it is clear for everyone, because according to theory, a function f such that x comma t and y comma v is continuous of x if and only if the inverse image of every v open set. I have already find out that what is the open set of the v. This is the open set of the v, and we get all the inverse is open set of the t. Open set of the t open set. P is open set is t open set. So it is clear. I hope you can understand this question. Now friends, question is going on G. Now my target is G. So I have already done the G functions. When 1 and when this is the image is A, and when 2 image is A, means this is the way. Okay, so now I have to check that inverse of the V open is also T open. So V open set of the phi, F phi, obviously phi. F phi is equal to obviously phi. Now F inverse A, whatever I get F inverse A equals to 1, 2. F inverse, sorry, the G inverse, because I find out G inverse. Now G inverse B, okay, open set of the G inverse B equals to phi, no image, so it is phi. G inverse A comma B equals to G inverse A comma B equals to G inverse A comma B equals to only 1, 2. Okay, G inverse A comma B and G inverse B comma C comma D. G inverse B comma G inverse B comma C comma D. G inverse B comma C comma D equals to, so B is phi and C and D is 3, 4. Now friends, 3, 4 is not 1 and 1, 2 also, but 3, 4 is not including, does not belongs to T. Okay, 3, 4 does not belongs to T. So G is not continuous. Okay, G is not continuous as 3, T 3, 4 does not belongs to 3, 4 does not belongs to T. Okay, must remember. I hope it is clear. Okay, it is clear. Please check total work and pause and write. A function f such that x comma t tends to y comma v is continuous on x if and only if the inverse image of every v open set is t open set. Friends, this is the very important theorem, and I prove this theorem. I prove the previous question with the help of this theorem. Okay, so you have to remember this theorem and note the characteristic functions of a subset of proper subset of x is continuous on x if and only if a is both open and closed on x. The characteristic function of a subset of x is continuous on x if and only if a is both open and closed on x. Friends, this is a proof I will not discuss, but you have to remember what is the characteristic function. Characteristic function k of a is kx, 1 when x belongs to a and 0 when x belongs to a. So it is clear for everyone.